So hey everyone, let's try this amazing question on tries or prefix trees, and we'll be doing it Google style with Google Docs. The very first thing is to understand the data structure, like what is this data structure and like what's the use of it, how it works, and once you have a basic understanding, I think implementing it would be really easy. Also, if you haven't checked out my implementation video on queues, definitely I would recommend to check out because that establishes all the basics or all the bases that are needed to solve this particular problem or just to have the code understandability for the problem. So yeah, the very first thing is try is like a prefix tree. It is actually used in cases where we want to know that if certain word, like if I write SCARC, maybe that would get auto filled in some way. Sometimes like if I write something like meetings or like nice to meet. So there are times when we are writing this, and what Google does is that it will try to autofill that. At the moment, it is not trying to autofill anything, but yeah, usually the way that works is that it is actually capturing that, yeah, what is my prefix and how can I actually fill it, or even this like uh, what's my spell checker saying, like and what would be the particular kind of suggestion that it could give. So if I write something like this, and maybe it will just suggest me, yeah, this was the word that could be, yeah. So we are seeing a real life use case, and we'll be seeing more such use cases when we make the thing that would look like an autocomplete in some way. So a try says that I would want to know at each character. So let's say each character for try is like stored separately. Let's say if you want to store a cat in try, then the C would be stored separately, the A would be stored separately, and the T would also be stored separately. And these are all stored in something called try nodes. Try nodes. And each try nodes has two things, which is like what's my children or is end of word. Yeah. So is end of word and children are two things that it has. A children is actually the way that one of them, let's say C, connects to the other ones of them. So the children is actually again a try node, and let's just understand how and why. So if I have something like C of cat, the C is a try node that has its own set of children and end of word. Inside of C, like inside its children, we would have A that exists, and it would have its own children and end of word. And then inside of this particular A, we will have this T. So the way we would be like traversing towards this is like if we have a root which is like my try node, or which is like C. So if I just make this dot root and I just make a const node to traverse this. So the only way I can traverse this is if I do node is equal to node of char dot children and dot node of children char. Yeah. So this is the only way I can traverse. Let's understand why. Because each of them has children, and the children is an object which would actually have that particular A. So let's just try to implement or make this like how would it look like in a try. So in a try, the way it would look like is const node or const root is equal to, and the root would be equal to something like, the first one is a try node, which means that it has its own children and character of word. So something that has children, and that children could be having like C, this value C, and is end of word, which could be like false. And then this children again has another try node, which means that this again has this as the value of the C, which would give me another trie node of, let's say, having a, and this a would be having its own children, which is like a, and its own is end of word, which would be like false. So I mean, this goes like really deep, right? It is like we are having it inside of another, and this is like how it is going. And this a would again have its own children, which could have like t, and then again you get the idea. Like its end of word would be true here, because now we have reached the end. Or we can even continue after the end, because it could be like we have a word which has is as end of word true, like cat, and then we have another like cats, and that s with cats also is end of word. So this is like how we search inside a trie. We check that, and this to show this better would be to show it with arrows, and I would just insert a drawing here. I think that would be much understandable way. So yeah, and some text. So my C here, and I can just use this and copy this with A and T, and I can just point some arrows to them, like yeah, C to A and A to T. We are getting a kind of a trie, and finally here my word is true. But also it can happen like we have C A and we have another word like CAB, cab is also a word. And when we are inserting a word, this is how trie does its job the way it does, and this is why it's like so powerful. So we have like CA and not C, I mean this would be like B. And how you can create any number of words, and you can see that every time we will be able to reuse a word which is like a word start, and we would be able to create more and more words. And this is how it would be able to take down a path and maybe make or give me an autofill option, like yeah, you can fill it with this, because if I go to children, I will be able to find, and I will be able to see if is end of word exists, so I can just help you out there. So this is like how an autofill works. Or it can just see in spell checker this is giving me false, but the nearest children is like something that give me another word, like autofill does that for me, or spell correct does that for me. So these are some of the use cases for that. And once we have understood that it has children is end of word, we would also be tracing it with dry run and understand how it is working, the way it's working. But let's first jump ahead and start coding, because we have got enough idea of the basic functionality and what is like this all about. So what I will do is I'm going to just make sure that I have a full page for my code. Let me just get this smaller and smaller. Yeah, and now I will be just going to the next page, and because we are coding, I will be using consolas. And this was all about like we should write it always think, like this was my thinking about this trie. So the very first thing is trie node, const trie node, and it should actually be class trie node constructor, and this would be calling two things, this dot children. So every trie node has child, and this would be like is equal to an empty object, and this dot is end of word, which could be like false. So yeah, this is all about trie node. You will be just reusing this trie node to create new nodes. The same way we have something like nodes in a linked list or nodes in a tree, and we would be just making more and more nodes with this. So now the thing is trie, and we would be making a constructor. We already know that each of them would be like this dot root, getting its value from this is equal to new trie node. And yeah, that's all that it has to know. That it has to know its own try node and which has children and is end of word. So there are like three functionalities that we would be caring about, which is like written in my question here. Like how can we insert an element, how can we search an element, how can we check about a starts with, and yeah, this is insert and search again. So just three functionalities that we have to care about. And the very first functionality is insert. And what would be here? A word, maybe a word. Yeah. And for const character of word, like we want to have a for loop with it and just go every character. And because we are inserting a word, const node is equal to this dot root, so I can get a copy of the what is the starting root, and I can just like we do a traversal and get I is equal to 0, then we do I plus plus. Here to do a traversal you have to do node is equal to node dot children char. But there could also be a case, right, where this char does not exist, right? So we will have to always check if and we would be checking if we have this character already or not. And if we have it already, we can just keep moving because we don't have to insert a new character. But if we don't, then we will have to insert, right? So if not of node dot children char, and we would be just asking, yeah, if you do not exist, we would help you create it. So node dot children char is equal to new try node. And yeah, we are done. So we just want that if you do not exist, if this character does not exist, then associate a try node with it. And whenever we have associated a try node, we are automatically moving to its children, like because node is equal to node dot children char, and it would just keep going inside and inside with each of the node children. This is how we are iterating. This is how we are moving forward. This is our I plus plus for this. And we are just checking if you do not exist, we would create a new word for you. Like this cat had this cab created just because of this insert. And yeah, this is it. This is the whole thing that you have to care about, this new try node and the creation with node.children. Let's create another one, right? We are just right into this pace here, and we want to create another one like search. So searching a word is very similar to insertion. I mean, all three of them are very similar. We need to just create a const node is equal to this dot root, so that we can actually move into the try. We can make a for loop again, const char of word, because we have a word and we want to go character by character, and this is how each character is stored in a try. That's the logic here. And yeah, this is for my for loop, this is for my search. So then I'm again going to ask if this does not exist, if the word does not exist, and because we are searching here, then return false, because the word does not exist, right? The word should have existed. And then we will have to, because we are still inside the for loop and this was just an if, and because I can just have one line like this, that's okay. I do not have to use curly braces for this. And then I can ask, yeah, no, not this, we do not have to insert, we have to search. So we will just go one level forward. Yeah. So I am going word by word inside it, and I am checking that in my for loop, and I will just indent it so you can understand this better. Yeah. So I'm just saying that if my character of word, and if my word does not exist, then return false. But if it exists, just keep moving. And after, when I have reached the end, I will just check node dot is end of word is true or not, is end of word, which means that yeah, the word is till now I have got, but is the word like CA and the T is missing, so it's not end of word, so we cannot just say it's true. And yeah, we just return it. Now let's go to the next one. We have created search, we have created insert, and the third one would be starts with. So we are going to check if our try starts with a certain word or not. So it would be like starts with, and because this is not a whole word, this is like a prefix of a word, so we will just write it prefix. Again, we will create const node because we want to loop inside, we want to have our for loop running, and this is like our I, which is incrementing. We are going inside and inside and inside every time the node is getting a newer value, and we are able to have our for loop running with this help, and be able to see each of the characters of for loop with the help of our node. So for char of word, so we would be running every character, and we would be checking if not of node char, like if the word does not exist. I'll just do one thing, yeah, just make it on the next page because the code is so big it doesn't it takes more than a page. So we are just again saying if your word does not exist, like if this character is not in the children, then do what? Return false, because my word cannot be auto-filled or something like that because the word doesn't exist in the first place. And yeah, this is for my for, this is for my function, this is the end of class, and this is my end of starts with, yeah, and this is my end of for loop, yeah. So now we are going to ask that, because this is like we are done away with this, like if you do not exist then return false, but if you do exist, just keep running this, just keep going to the next node, to the next node, the next node, and in the end we do not want to check if it is end of word because it doesn't matter. We just want to return false, we just want to return true. Why? Because in this case we search and check that yeah, we have gone through each of the word, but are you the end of the word? Are you like a cat, or are you just like ca? Do you have his end of word true, or do you have his end of word false? But for this one we just wanted to get the prefix, right? It doesn't matter if it is just c that we are getting, or it doesn't matter if it's just ca. If you are able to have all the characters that exist in my try, then I will just return true because I know that you are a prefix of some word that exists for me, and that's what I have to check. And yeah, I think that this was like really great, but now let's make it more great by tracing it with a pen and paper, and we would be just checking it against the output that we have here, right? So let's do that. So the thing that Google Recruiter would love, that if you would just write something like, oh, what's this? If you can just write something like dry run here, and if you are making any comments, you can just use this. These are just very small things to have those fun moments in the interview, and this, and yeah, use console as when you can. So now we have something like a dry run. Here we can just use Arial, which is like accessible font, which is good. So we are creating a try node. So in the very first phase, our try would be created, our node would be created with the root. This is like okay, doesn't matter what is this. Then we have to make an insert. So an insert would be like we are inserting apple here. So it would be inserting, like let's say we have this word apple that comes here, apple. I'm just going to use green, yeah. And once we have this apple, then it is going to see that yeah, does node has this dot root, which is like we are just getting the try node for character of word. If node dot children dot char, like if you exist in the roots children as char, because you know that this children has like the keys are the whole letters, so the key char would have like its own try node. So either you exist, and if you do not have this kind of existence, then I'm going to create your existence by giving you this particular char. So you will have your own key as this particular letter, and you will have your try node which has more children and end of word like this. So this is done greatly, and the next thing is now I will just move into this children for a, and now I am here. This is my own try node. It's created or it already existed, doesn't matter. Now I will just loop into it and again ask that yeah, does p exist after this? And if p exists, then we would be just using that same p and just moving inside and create another p inside of this p. Or if it does not, then we would be just making it inside of a. We would be having this p set up as a try node. So every time we are moving one level inside, and this is how, and this is like the whole basis of try or prefix tree, and this is like really interesting, like how it works. The next thing, when apple is done, like we would also want to search apple, and because we are searching a word that we already have, I know that it will return true. It's that how will it return true that matters for me, right? We have to capture that. So we have apple here. We are getting this dot root. We are going to check character by character of our try node. We will be going to a p p l e. If you do not exist, like if the any character is not there, just return false. Just move out of the loop. I do not want to care about what's next because you do not exist. But if it does, then just keep moving inside and inside and inside, and then at the end just give me is end of word true. And I think this is important because here we have missed out something, that when we are done with the last character e in apple, after my for loop ends, then I had to do something like node dot is end of word, and I will just tell you why is true, and it will make sense to you, because I have inserted apple and I won't want that if someone is like appl and he gets is end of word is equal to true. Is end of word is by default false, and it's like always created as false. But now we are creating it as true because apple has eve in it, which is the last word, and after my for loop has ended, this is the last word I am at. So why not give it a chance and give it true, because this is like really the end of the word. And here in search, that would be helpful because we are checking if your search word is like end of the word, or if it is like not a whole word, because that wouldn't make sense to be in search. That would be in starts with, and this is the difference, like why we are creating two different ones. So yeah, it checks the is end of word, and because we have made the e have this is end of word, then it's like good. If we have also inserted something like app, then it would have just gone through the same app, and at the last when it reaches p, it would have just given it true. It would have not created a new try node because already it exists in the same order that we already have. So yeah, something like then app, if we would have searched, then it would also have given us true. In this case we do not have inserted app, so if we checked for something like app, it will actually give us false because it will not have its end of word. I hope that makes sense. And another search with app, yeah, as I was saying, so if we search with app, it will return false because the word does not exist. But if we check with starts with, and now let's come to this really great one, function that we have. So with starts with, we will be checking that, yeah, we still have my node so that I can just traverse inside, check each of the children's character, and for each char of word I'm just seeing that, yeah, if you do not exist, just leave it because the word is not there, just return false. But if I have just looped through successfully and I have never returned false here, the function never returned anything, now I have the chance to return true because this word indeed existed and is a prefix that exists. And yeah, that is all about starts with. We can again do an insert and again do a search. It will give us on insert it will give us null because no, we are not returning anything, and then on search it will give us true because now the word app exists. And yeah, that is all about try. I hope you liked it. This is like one of the lead code medium level problems. I think that this is also one of the foundational things because try is like one of the important concepts, and maybe there could be multiple questions at Google, especially in software engineering side, where they could ask you about try, not directly, but there is also a chance they could ask you to simply implement it. And yeah, I hope this helps, and just see you on the next one. See ya.